and I have fun. Okay, so we stopped at this 122.7. We talked about ATP. So simplified structure, it's triphosphate, the ribose, and the adenine. As we're looking at ATP. And I think that was already in your thing, right? No, we didn't get that written down. Some did, some didn't.
Yeah, I just read.
Goodness gracious, I can fly with all those balloons. Okay, ADT, ATP cycle. So we've got a motion active transport biosynthesis that goes to ADP, which then goes to oxidation of fuel molecules, which then goes to ATP, which is triple the phosphate instead of diphosphate, which goes back to the motion active transport biosynthesis.
Okay, the one that I found said it's like ATP to energy from the cells, and then like to ADP to energy from the food, like fuel.
Right. Okay, so going forward, we okay? All right, so this is a long version. That was a short version. So high energy molecules are unstable, reactive, and with respect to hydrolysis. The delta G for them is very, very small, a lot less than 0. So, and we have phosphoryl transfer. So when we have a water attach, the water pulls this off and we get ADP and phosphate. Then when we want to put it back on, we have to dehydrate it. So we have to dehydrate it and put the phosphate back on. So just a way to look at it, you can see the oxygens. I like to count the phosphorus. I know they count the oxygens here, but ADP has 2 phosphoruses, ATP has 3. And moving from, anyway, I don't know if that, I think I gave you those, so you didn't have to draw them. So here we have phosphoanhydride bonds with ATP and ADP, just another way to look at it. And as we look at it down here at the bottom, where I got my stuff right here, the delta G is a minus 7.3 kilocalories per mole. So it likes to go that way. High energy compounds, a substance that on hydrolysis liberates a great amount of energy, would be these top ones, the phosphophenylpurate, carbonyl phosphate. You can read all those, they're lovely. And then we have the ATP going to ADP plus 1, and the ADP going to AMP, which is just 1 phosphate plus a phosphate added on. And then you've got the low energy compounds that are below that. The AMP is a very low energy compound. So ATP and ADP sort of split the high energy and the low energy. Just got to remember that. Okay. So here we go from ATP to AMP, where we get the PPI. In other words, 2 phosphates have taken off. You can see over there on the far side, it gives you delta G at each one. And ATP gives the biggest amount, going all the way down to AMP. So we're going to look at Chemistry Around Us 22.2, calorie language on page 733. A lot of you have already talked about this a lot, but we're going to go through this, see what it means to be calorie-free, low-calorie, reduced or fewer calories, light, and all that fun stuff. So I'm going to stop it for a minute, and we'll come back. Blobbed on for a while. Okay, so what does calorie-free mean? Oh, so it's really not calorie-free, right? It's less than 5. Yeah, there's some over there by the Lysol. Okay, low calorie, what does that mean? So less than 40. And reduced or fewer calories, how do they get that? 0.5% less. That is not a lot. So I'm going to go for the Reese stuff because it's better for me. Just barely. And what does light mean? 50% less fat. Okay. I really want one of these bunnies right now. but I want it solid. I don't want hollow inside. Oh, caramel would be awesome. Squish. I know. It'd have to be caramel chocolate, caramel chocolate, caramel chocolate, caramel chocolate, caramel chocolate. With nougat in the very center.
Or even have a layer of fudge.
Fudge would be good inside. I wouldn't mind nuts in there, but I know some people don't like nuts, but I do too. Okay, we got to focus. Sorry. Mitochondria. This is, if you've had biology before, you should know what a mitochondria is, right? Okay. A cellular organelle where the reaction of the common catabolic pathway occur. And you do need to know these pieces of what is going on here. I'm going to move this off to the side again. Okay, so enzymes of citric acid cycle and electron transport chain are in this center part here. Okay, you've got the matrix, you've got the outer membrane, you've got the cristia, you've got the inner membrane, the DNA, the ribosomes, and the intermembranal space. You've got to have some space, man. Sorry, I just remembered something from 7th period. Made me laugh. I know. All right, so we do need to be able to recognize this, and you need to be able to identify the parts if you are given a picture like this. Okay? Did we get all of the parts down? Forgot the top.
I got
Well, you guys make a good pair.
They are like a very to begin with, I think.
I noticed, though, they've spread out. You're every other seat now.
I know, what's up with that?
You have more room.
I was
Okay, we ready?
I sit by people, but I'm
if you need it.
Well, you have your own whole row.
yeah.
And then Gio
so
is
many
back.
people.
Does Gio ever putting his bag and stuff on your table?
Oh.
Your bag's right here. Up on my desk. I'm like, why are you sitting right here?
Okay, let's go on to this. Important coenzymes in common catabolic pathway. We've got the thioester. Remember, the thioester is just an ester with a sulfur instead of the oxygen. And it's connecting a CoA. So coenzyme A is a central compound in metabolism. As we look at coenzyme A, it has specific parts. We've got the beta, MERS, don't ask me how to say that out loud, ethylamine. MERS, aptoethylamine. I told you organic molecules were never meant to say out loud. Okay? And that because they're named systematically, but they're not named English grammar-ish.
Then we changed the name to something like sugar. And then we're like, why the heck do we even go through that process to call it sugar?
Okay, so we also have the adenine 3 diphosphate on the end. Okay, so we sometimes just simplify it down like this. And I don't know what you need to write. Are you okay?
I think we got that whole thing.
Okay. Sometimes I was nice and sometimes I wasn't. Okay, so then we go on to this next part where we have the coenzyme NAD plus and NADH. The oxidized form is NAD plus, and the reduced form is NADH plus and H plus. So as we're going back and forth, depending on if we're going through oxidation or reduction, it's just changing that top part. And if you'll notice up here, it's sort of highlighted in blue, which sort of makes me crazy, but it's right here. So it would have been right here. Okay? So that's where it's taken that H from. And you just need to know the difference between the two. And which one is oxidized and which one is reduced. Are we okay to go forward? All right, so general reactions. As we're looking at alcohol and we add NAD+, we're going to get an aldehyde and we're going to get NADH. Okay? Where we're taking a hydrogen off, putting it on here, and we're getting an extra hydrogen from the process. Do you guys not have that?
I don't know, we have a bunch of equations.
Let me
I
see.
don't think we do, but I'm honestly unsure.
Do you have that one?
Yeah, we have that one.
Okay, so I'm just going to talk about this one for just a second and then we'll go on. So we have an alcohol, it goes to an aldehyde. If we do it again, it goes to an acid. So that's how we get through doing our general reaction here. So as we look at the coenzymes FAD and FADH, it's easier to say it that way than the real name. We're doing the same kind of thing. This is all part of our electron transport chain. As we're going down, I tried to find one that would show you what's going on in different places that would highlight when a hydrogen came off and how it was transported. Okay. So enzymes that are used in FAD give up 2 electrons to the coenzyme. However, the FAD coenzyme accepts both hydrogens, atoms lost by the substrate. So instead of going just to FADH, it actually goes to FADH2. So this is a whole chain going on. Whereas the NAD only went to NAD and NADH. So general reaction, we're going through something like this, we get this. So we need to recognize that these are going to go both onto the FAD, and this becomes a double bond. Okay? And they can get pretty fancy. All you need to know is that it's going to happen. You're going to get a double bond. So if they give you something fancy like this right here, you just need to put a double bond over in here. Okay, don't put it real close to the end. Put it closer to the, you'll notice that it went the first one that it could handle a double bond after the oxygen. Okay? All right, so now we're going to ask the experts, is it better to take a fiber supplement or eat fiber-fortified food? All right, so let's just go for a second really quickly and just go into this because there is a question on this, and we'll come back and talk about it real quick.
Kind of a general thing with health stuff, though. They're like, this does this, and then everyone starts talking about it, and they're like, wait a second.
No, it doesn't.
Well, in science, everything we do is going to make us have cancer.
True.
Yeah. You just don't like
It just depends on your risk. I mean, how much you eat of it. It's moderation in all things.
Yeah, it's genetics, it's food, it's radiation exposure.
Okay, so what did we find out about fiber?
It can be healthy in the tablet.
It can be healthy in the tablets.
Yeah.
Is it better in the tablets or in the real food?
It said it was in the tablets. Yeah. I think it said. Oh. It says either way. Either way, depending on the person.
That's relevant.
It also depends on the kind, because some, like, for example, like the gummy vitamins for kids have tons and tons and tons of sugar in it.
So it depends on what else is in it. That's fiber, you know, the gummy bears for adults too. That makes us eat our.
I mean,
I feel like the fiber, like in the food,
apples are
works a
just
lot
straight
slower.
fiber.
It works slower. Okay.
and it like
Skin
stays
insoluble.
to health.
Well, with the food, you're eating it more times a day than you are with a supplement. Usually, supplement you have it once, and so then you have this big clean. It's sort of like waiting all month to clean your house. Cleaning your house, it gets really clean, and then not cleaning again for another month. So the fiber tablets are sort of like that if they're not time release. So it's like cleaning your house really fast and then letting things build up, cleaning your house really fast. And so it's more gentle on your system to use food because food comes through slower and you're eating constantly. So if you're eating constant, yeah, you hire a maid. Constantly cleaning, you know, and then you don't have the big clean because it's always nice. Does that make sense? If you clean a little bit each day, keep things up, it's not that horrible, nasty month-end clean. Okay. All right, so we are going to work on now your assignment number.
Cleaning.
Take turns reading the concept summary to each other. Oh, we didn't take turns.
So we're gonna go to the concept summary.
Oh, that's different.
That's in the back. And I want you to just pair up. We got enough to pair. And I want you to take turns reading a section to each other back and forth. Trying something different. We'll see. Okay, so when you start seeing your worth, you'll find it harder to stay around people who don't. It's your time. Do it now. Sometimes later becomes never. For your last little law to help you. Okay?